In this video, we will be discussing question number 20 from Chemistry Gate Exam 2022. The question is, 1sa and 1sb are the normalized eigenfunctions of two hydrogen atoms Ha and Hb respectively. If S equal to bracket 1sa 1sb, the option that is always correct is options S equal to 1, S equal to 0, S equal to imaginary constant, or S lies between 0 and 1, including 0 and 1. So let's see how to solve this problem. It's given that S equal to bracket 1sa 1sb. That can be written in integral form, that is equal to integral 1sa 1sb d tau, and that is known as overlap integral, which explains the extent to which two atomic orbitals on different atoms overlap to each other. And the detailed version for this overlap integral will be SR equal to bracket 1sa 1sb equal to e to the power minus r by a0 into 1 plus r by a0 plus r square by 3 a0 square, where r is the distance between two orbitals. And obviously this overlap integral is a function of distance between the two orbitals. Consider 1sa and 1sb being separated with a large distance. Obviously the overlap will be very less, hence S will be a small value. And imagine 1sa and 1sb are very close to each other, then overlap will be more, S will be having a larger value. This is plotted here, which is the overlap integral S between two hydrogen 1s orbitals as a function of their separation r. And we can see that as r by a0 ratio is increasing, the value of S is decreasing and reaches almost 0. And the S is having highest value of 1 when r by a0 value is decreasing and reaching towards 0. Now we have this 1sa 1sb orbitals. The maximum value can be 1 when the 1sa and 1sb are coming closer and perfectly overlapping to each other at a distance r equal to 0. Another scenario is the minimum value of overlapping, which is at r equal to infinity. There will be no overlap, and at r equal to infinity, according to the plot, the S value will be 0. So there is no chance of any other imaginary values, but it lies between 1 and 0, and it can be 1 or it can be 0 also. So the question was to find out the option which is always correct, and now we have the answer. The S lies between 0 and 1 and not any imaginary constant. So the correct option is D. For more details, you can go back and check NPTEL lectures, Molecular Orbital Theory for H2+ by Anindya Datta, and the link for the lecture is also given here, the YouTube link. Thank you.